Welcome you students. We are going to see Laurent series expansion problem. In this example, expand f of z equal to z square by z plus 2 into z minus 3. In a Laurent series expansion, if mod z is less than 2 and the second region is given as 2 is less than mod z less than 3, which is the annular region between the circle with center 0, 0 and radius 2 and 3. So if you are seeing this function, we are having f of z equal to z square by z plus 2 into z minus 3. The power of numerator is equal to the power of the denominator. Therefore, first, before applying Laurent series, we have to reduce the power of numerator than the power of denominator. For that, we know what is z plus 2 into z minus 3. It gives you z square minus z minus 6. Divide z square by z square minus z minus 6. That gives you 1 is the quotient and z plus 6 is the remainder. So now you can see that this power of numerator polynomial is less than the power of denominator polynomial in z. We can proceed it now. Here z plus 6 divided by z square minus z minus 6. I can write it as z plus 6 divided by z plus 2 into z plus 3, z minus 3. Now break it up by making use of partial fraction method. So you can write it as a by z plus 2 plus b by z minus 3. By finding the value of a and b, take z equal to 3, you will get the value of b as 9 by 5. Take z equal to minus 2, you can able to find out the value of a as minus 4 by 5. Substituting these two values here, the function f of z will become 1 minus 4 by 5 into z plus 2 plus 9 by 5 into z minus 3. The first region given as mod z is less than 2. We know the binomial expansion of 1 plus x or 1 minus x whole power minus 1 valid only in the region mod x is less than 1. So we are bringing this region mod z less than 2 by modulus of z by any constant less than 1 format. So divide both sides by 2. You will get mod z by 2 is less than 1. Here we are having the circle. We are dividing that circle part into 2, which is less than 1. Therefore, by dividing the circle part into 3, definitely less than 1. Why we are taking divided by 3? Because if you are seeing this first term, you are having 2 is coming, whereas in the second term, you are having 3. That's why we are writing modulus of z by 2 is less than 1. Definitely implies that modulus of z by 3 is less than 1. Now apply this region in the separated terms. So you will get from the first term, if you want to apply this region, you have to take 2 outside. That gives you 1 plus z by 2. In the second term, if you want to apply this region, you have to take 3 outside, which gives you 9 by 5 into 1 by 3 into z by 3 minus 1. I am going to make it as 1 plus or minus x form. So I am taking minus sign outside. 1 minus this 2 and 4 gets cancelled. 2 by 5 into 1 plus z by 2 the whole power minus 1. Then by taking this minus sign outside, you will get minus 3 by 5 into 1 minus z by 3 whole power minus 1. Now apply the binomial expansion. You will get Here positive and the power is negative, therefore alternative terms are going to be positive and negative. And in the second term, 1 minus x power minus 1 form. So alternative terms are not going to be negative, all are positive. Now write down the generalized form. You will get 1 minus 2 by 5 sum of n equal to 0 to infinity minus 1 to the power n into z by 2 the whole power n minus 3 by 5 into sum of n equal to 0 to infinity z by 3 power n. So this is the expansion of the series in the contour mod z less than 2. You can observe here we are having only positive powers of z. Therefore, you can call this as Taylor series also. In some of the problem, if they are asking Taylor series expansion by having this kind of problem, then you can proceed it in the same way. From the answer, you can see that you will have only positive powers of z, positive powers of z minus a. So come to the second region, you are having 2 is less than mod z less than 3, which is the annular region having the center as 0, 0 and radius as first circle is 2 and second circle is 3. Now, in this region, we can write it as mod z greater than 2 and mod z less than 3. So, both parts you have to bring it as like modulus of z by any constant is less than 1 form or constant by z is less than 1 form. So, you are going to divide or you are going to take the inversion of this. You will get 1 by mod z is less than 1 by 2. Bringing this to this side, you will get 2 by mod z is less than 1. Likewise, dividing this part by 3, left hand side as well as right hand side, you will get modulus of z by 3 is less than 1. So this region where you are going to apply, if the term consisting of 2, you can apply this part. And if the term containing 3, you can apply this region. Here you can see here f of z equal to z square by z plus 2 into z minus 3. We are having 1 minus 4 by 5 into z plus 2 plus 9 by 5 into z minus 3. So here you are having z plus 2. Therefore this region we are going to apply for this part. And z minus 3 we are having this region we are going to apply for this part. So if you want to apply this 2 by mod z, you have to take z outside from this term. From the second term, you have to take 3 outside. By taking like that, you will get minus 1 minus 4 by 5 into 1 by z into 1 plus 2 by z plus 9 by 5 into 3 if I am taking outside z by 3 minus 1. So 3 gets cancelled. We are going to get 1 minus 4 by 5z into 1 plus 2 by z the whole power minus 1 minus 3 by 5. We are taking minus 1 outside minus 3 by 5 into 1 minus z by 3 power minus 1. Then writing the generalized form, you will get 1 minus 4 by z sum of n equal to 0 to infinity minus 1 to the power n, 2 by z the whole power n, minus 3 by z into 3 by 5 into sum of n equal to 0 to infinity z by 3 whole power n, which is the required answer for this problem. So this problem gives you the method when the polynomial degree of numerator, if it is equal to or greater than the polynomial degree of the denominator. First, you have to bring it as the numerator polynomial degree should be less than the denominator polynomial degree, and then only you have to start doing the problem. Thank you.